Hello everyone, I'm Alvin Pratama, lecturer in Atmospheric and Planetary Science, Institute Teknologi Sumatera, and today we will talk and discuss about climate change cause and impact on our life. Climate change is one of the most popular global issue of our time. It affects not only the environment but also human health, food security, water availability, and even the stability of communities. In this session, we will explore what drives climate change, the science behind it, and the visible consequences we are already experiencing. By understanding the root of causes and the impacts, we can better prepare ourselves to face the challenge ahead and, more importantly, take meaningful action. So let's begin our discussion with the basic question: what is climate change and why it happened? As we know that climate change has become one of the most popular global issues in recent decades due to its wide-ranging effects on Earth's atmospheric system. It leads to significant change in temperature, precipitation pattern, wind behavior, and other climate variables that occur over long periods. Before we talk further about climate change, it is important to understand the distinction between the weather and climate. Weather refers to the short-term atmospheric condition in a specific time and place, such as rain, sunshine, humidity, or temperature that occur over hours or days in short time. In contrast, climate refers to the long-term average of weather patterns, usually measured over a 30 years period or more. Therefore, climate change is not about daily fluctuation, but rather about a persistent trend in temperature and other indicators over extended time frame. That's the differences between the weather and climate. And in the slide, we see that the graph in this slide show the temperature anomalies recorded by the various global climate monitoring agency, such as CRU, NOAA, ECMWF, and Berkeley Earth. Despite using different data source and analysis techniques, all these agencies report a consistent upward trend in global temperatures anomalies. From this data also, it is clear that global temperature have been increasing more rapidly since around 1980s. And according to the Berkeley Earth datasets, which is also shown with a 95% confidence interval, the Earth's average temperature anomaly reached approximately 1 degree Celsius above the average temperature data over 30 years. This trend indicates a significant warming of the planet over the past few decades. This finding also highlights the scientists' consensus that climate change is happening and accelerating. The continued increase in global temperature is strongly linked to human activities that we will talk more in the next slide. And before talking further about the climate change, we also have to understand why this can happen. And this is also related to the concept of the Earth energy budget. The primary source of energy for our planet is the sun. We also know it. It emits energy in the form of electromagnetic radiation, mostly in the visible and ultraviolet spectrum. According to the diagram you can see in the slides, the total incoming solar radiation reaching of the planet is approximately 340 watt per meter square. You can saw in this incoming solar radiation. However, not all of this energy is absorbed by the Earth system. A portion about 77 watt per meter square is reflected by the clouds and the atmosphere. You can saw in this picture. And about 22 watt per meter square is reflected by the Earth's surface. In total, around 99 0.9 watt per meter square of solar energy is reflected back into space. Um, the remaining energy, approximately 240 watt per meter square, is absorbed by the Earth. More specifically, 77 watt per meter square is absorbed by the atmosphere, and 163 is absorbed by the surface, or around 50% of the solar energy absorbed by the surface. And to maintain the stable climate, Earth must be re-radiate the same amount of energy it absorbs. This is the concept of Earth's energy balance. The surface emits a long-wave infrared radiation, which is a form of heat energy. And an ideal balance, the outgoing infrared radiation should match the absorbed solar radiation. However, this balance has been disrupted. A significant portion of the outgoing infrared radiation is absorbed by the greenhouse gases in the atmosphere, such as carbon dioxide, methane, and water vapor. And instead of allowing the energy to escape into the space, these gases re-radiate part of it back into the Earth. That's why our Earth become warm, and this process known as the greenhouse effect. Uh, these slides introduce the key terminology when we talk about the climate change, and it helps us understand the mechanism behind the climate change. First, we have the greenhouse gases. These are gases like carbon dioxide, methane, and other gases. And what they do is absorb infrared radiation or heat from the Earth's surface. Instead of letting the heat escape into the space, they trap it in the atmosphere, and this is what contributes to global warming. Next is the greenhouse effect. This is the process where the Earth receives energy from the sun in the form of light. That energy is absorbed by the surface and then released as heat or infrared radiation. Greenhouse gases absorb some of the heat and send it back to the Earth, which raises the planet temperature. This effect is natural, but human activity have made it much stronger by increasing the amount of greenhouse gases in the atmosphere. And next is infrared radiation. This is the type of the radiation that carries heat. It has a wavelength that's longer than visible light, but shorter than radio waves. Most of the heat from the Earth is in the form of infrared radiation. Lastly, we have positive feedback. This means that a small change can lead to even bigger change. For example, when ice melts due to warming, it exposes darker surface like ocean or land. This darker surface absorbs more heat, which causes even more ice to melt, and the cycle continues. Understanding these terms help us to see the bigger picture of why climate change is happening and why it is important to take action. And now let's talk about the greenhouse gases in 2020. We see three major greenhouse gases: carbon dioxide, methane, and nitrous oxides. Each of these has increased significantly over time. You can see carbon dioxide reached 413 ppm in 2020. There is about 149% increase compared to the level before the industrial era in 1950. And carbon dioxide is the largest contributor to global warming, account about 66% of the impact. Next, you can see the methane, which hit 1,001.88 ppm. Methane is especially potent. It's more effective at trapping heat than carbon dioxide. even though it exists in smaller amounts. Since the pre-industrial era, methane has increased about 262% and now contribute around 60% to global warming. And the last, we have nitrous oxide, which reached 333 ppm. That is 123% increase since 1750. It contributes about 7% to global warming. And at the bottom of the chart, you can see the contribution of these gases to global warming. Carbon dioxide is far the biggest contributor, followed by methane, nitrous oxide, and other gases. And next, let's discuss what actually causes the Earth's climate to change. The first, you can see there's change in the atmosphere play a major role. The composition of gases in our atmosphere determine how much heat is trapped and how much escape into space. An increase in greenhouse gases like carbon dioxide, methane leads to more heat being retained, which rises the Earth's average temperature. Next, we have a natural process that also influence climates. For example, volcanic activities can release large amount of the ash and gases into the atmosphere. This can temporarily cool the Earth by blocking sunlight. Another natural factor is tectonic plate movement, which can shift the position of the continents and ocean, affecting the wind and ocean currents over a long time of periods. And the change of the sun is another contributor. The sun's energy output is not constant. It can vary slightly, and this affects how much solar energy reaches the Earth. And the shift in the Earth's orbit, also known as Milankovitch cycles, occur over thousands of years and can cause change in the distribution of sunlight over the planet. And the last, most importantly, today we have human activities. These include burning fossils, fuels, deforestation, and industrial process of this release the greenhouse gases into the atmosphere. Intensifying the natural greenhouse effect from the human activities. And unlike natural change, human-induced change are happening rapidly and global scale, making them the main driver of current climate change. So while natural factors do influence climate, it's human activities, especially in the last century, that are the leading cause of the accelerated warming we are seeing today. And this is anthropogenic cause of the climate change, as we've seen in the previous slides. There are both natural factors and human activities that drive the climate change. Natural process include a volcano eruption, tectonic shift, and change in the sun and Earth's orbit. These have influenced climate throughout Earth's history. However, what's most concerning today is the rapid change caused by human activities. This is the biggest drive of the warming we are currently experiencing. And now take a look of this. Take a look of this image. This is the example of the human activities. The first we see bush burning when forests or grassland are burned, whether naturally or intentionally. It releases a large amount of carbon dioxide and other greenhouse gases into the atmosphere. This contributes significantly to the global warming. Next, we also see car exhaust. The transportation sector, especially cars and trucks powered by gasoline and diesels, is a major source of the carbon emission. Every day, millions of the vehicles release carbon dioxide and pollutant into the air, adding to the greenhouse effect. And the last, we also see the industrial plants, factories, and power plants release massive amount of the greenhouse gases, especially when they burn coal, oil, or natural gas for energy. These emissions have been increasing rapidly since the Industrial Revolution. So while the natural process has still play a role, human action like burning fossil fuels, deforestation, and industrial pollution are the main cause of accelerated climate change. And as the image show, these activities are happening all around us every day and every time. And another important concept about the climate change is the global warming potential, or GWP. GWP is a measure used to compare the impact of the different greenhouse gases on global warming. It tells us how much heat a gas traps in the atmosphere compared to the carbon dioxide over a specific period of time. Carbon dioxide is used as the baseline with a GWP value of 1. Now, if you look at the table, we can see that some gases, even in small amount, have a much higher warming effect than carbon dioxide. For example, methane has GWP of 21 and a lifetime about 12 years. This means that 1 ton of methane has the same warming effect as 21 tons of the carbon dioxide. Nitrous oxide is even more powerful with a GWP of 310 and a much longer lifetime of 114 years. Then we see the industrial gases like sulfur hexafluoride. It has extremely high GWP of the 23,000 and can stay in the atmosphere over 3,000 years. That's why it is one of the most dangerous greenhouse gases, even though it is used in small amounts. And such as CFC, HCFC, and others also have a very high GWP. So what does it mean? Even though we focus a lot of carbon dioxide, it's important to remember that other gases, while emitted in smaller quantities, can be far more powerful in terms of their warming effects and how long they stay in the atmosphere. This is why GWP is a critical tool for measuring and comparing emission, and it helps us guide international climate policies and regulation. And what is the impact of the climate change? We will discuss it in the next slides. Okay, the first, now let's take a look projected change in global sea surface temperature, one of the impact of the climate change. And as we know, over the past few decades, the ocean has been absorbing more heat due to global warming. This has led to a steady increase in sea surface temperature, which we can clearly see in the graph. The black line shows the historical trend until around 2005. After that, the colored line represents different climate scenario called RCP, representative concentration pathways. This range from RCP 2.6, low emission scenario, until RCP X.5, which is the high emission pathway or scenario. What's important to note is that under every scenario, sea surface temperature continues to rise. But under RCP 8.5, the rise is much steeper, reaching up to 3 degrees Celsius above the pre-industrial level by 2060. And this warming of the ocean has serious consequences. First, it leads to heat waves, not just on land, but also in the ocean, which can damage marine ecosystem. Warmer seas also fuel more intense storm, like hurricane or typhoon. because storms draw the energy from the warm water. Another major concern is sea level rise. As the ocean water warms, it expands, and this thermal expansion adds to rising sea levels, putting coastal areas at risk. Additionally, warmer sea temperature contribute to the melting sea ice and disruption of marine ecosystem. So the key message from this slide is clear. The more emission we release, the more heat the ocean will absorb, and the more dangerous the impact will be for both environment and humanity. And yeah, let's now talk about the impact, another impact of the climate change, which already being felt in many parts of the world. And from this slide, we can see the storms are becoming more frequent and intense. This storm bring heavy rain and flooding, which can damage homes, buildings, and roads in some communities, especially in low-lying areas. The damage can be devastating both physically and economically. We also see unpredictable and extreme weather. Droughts are becoming more severe, destroying crop and affecting food production. And at the same time, the region might experience excessive rainfall, leading to the landslide and flash flood. And moving to the next slide, change in rain and snow pattern are major concern too. Too much or too little water can disrupt agriculture, drinking water supply, and even electricity production from the hydroelectricity power. Yeah, the image on the right show melting snowpacks in many regions. Snow that accumulates during winter provide fresh water during the spring and summer. As snow melts earlier due to the warmer temperature, it affects the timing and availability of water in rivers, streams, and reservoirs. This puts pressure on water system that supply cities and towns, especially during dry months. And yeah, so climate change is not just about the rising temperature. It's also about changing weather pattern, threaten to infrastructure, and challenging to our water and food security. These impacts are becoming more visible and more dangerous, which is why urgent action is needed to reduce emission and adapt to the changes that are already underway. And this is the impact on human health. As we see in the diagram, climate change influences health in many interconnected ways. At the center of the image, there are three main drivers: rising temperature, more extreme weather, and rising sea levels. Each of these contribute to the serious health threats. Starting with the extreme heat, it can cause heat-related illness, cardiovascular failure, and even death. Severe weather like storm and floods can result in injuries, fatalities, and significant mental health impact. We also see change in vector ecology, meaning that the disease carried by mosquito or ticks like malaria, dengue, and chikungunya. And water and food security are also affected. Warmer temperature and heavy rains can contaminate water supplies, increasing the risk of the disease like cholera and other illness. Drought and floods also damage crops and food insecurity. And environment degradation can force people to migrate, increasing the risk of the civil conflicts, displacement, trauma, and other impact. So, the climate change is not just about the environmental issue, it is a public health crisis. Addressing climate change means protecting not only the planet but also the health and well-being of people, especially those more vulnerable. And yeah, this is another impact to ecosystem. This slide highlights the different type of ecosystem: agriculture, coastal, forest lands, freshwater system, and arid grassland. For example, agricultural lands give us food and fiber, while coastal zones help regulate the climate, support marine life, and protect us from the storms. Forests store carbon, produce oxygen, and maintain biodiversity. Freshwater system provide clean drinking water, and grassland are essential for grazing and soil conservation. But climate change is disrupting all of this. Rising temperature, changing rainfall, sea level rise, and extreme weather threaten the stability of this ecosystem. As a result, the production of food and clean water is at risk. Biodiversity is declining, which means many species, especially plants and animals, are struggling to survive. And this also affects human health, especially in areas that depend on the nature for food, medicine, and water. And climate change threatens the very system that support life on Earth. If ecosystem become too stressed or to function properly, we lose their ability to provide essential ecology goods and service like food, water, clean air, and climate regulation. And the last, this slide, is a powerful visual summary of the many environmental and social challenges we face on our planet. At the center is our Earth, our only home, but surrounding it, we see the damage caused by the human activities, industrial pollution, deforestation, waste and water crisis, overpopulation, and even environmental disaster. These images represent real world problems, communities suffering from poor sanitation, wildlife under threat, children without clean water, and lands get destroyed by fire and development. What this tells us is clear. The health of our planet is deeply connected to the health and dignity of human life. And the challenge we are facing now is how to manage the earth sustainably in the middle of the constant change, whether it is environment, economical, or social. Social. Uh, and yeah, let's conclude of our material for today. I hope you all found it clear and informative. See you in the next session where we will discuss about the climate change adaptation and mitigation. Thank you for your attention. See you.